Hello and welcome to Globe Data Fundamentals, Training 1. This training will teach you the basics about Globe data and how to access it and visualize it. If you have any questions, contact help@globe.gov. Alright, let's get started. The mission of Globe Data Virtual Trainings is to increase the use of Globe data by scientists for research. This is accomplished through online training that teaches participants how to access, visualize, and analyze Globe data. Okay, so first let's go over the training prerequisites, learning objectives, and training outline. This training really is the fundamentals for people who have little or no experience with Globe data. There are no prerequisites. This training assumes no prior knowledge of Globe or Globe data. The objective of this training is to answer the questions, what is Globe, what data are available, and how do I get the data? This training is organized as follows. First, I'll provide you a basic introduction to Globe. Then I'll talk to you about how Globe data is collected. Then I'll show you how to access Globe data. I'll point you to the documentation about the data. At the end, the training will wrap up with a short summary of the material covered and ways to stay connected with Globe. Alright, Section 1, an introduction to Globe. Globe stands for the Global Learning and Observations to Benefit the Environment Program. Globe is sponsored by the United States National Aeronautics and Space Administration, or NASA, supported by the National Science Foundation, National Oceanic and Atmospheric Administration, and Department of State, and implemented by the University Corporation for Atmospheric Research, or UCAR. Globe has been in operation since 1995. Globe is an international program with a large and diverse community. There are 121 participating Globe countries, more than 34,000 Globe schools, and more than 142,000 citizen scientists. Pretty amazing. Every year, Globe holds its annual meeting. The photo here on the right shows the 23rd annual Globe meeting this past July in Detroit, Michigan. Many, but not all countries are participating Globe countries. If you're wondering which countries do participate, shown here is a map of current Globe countries. You can learn more by going to the URL for the community map provided below. Now let's move on to talking about data collection. In this section, you will learn about what kinds of data are collected and how they're collected. Who is collecting the data? Globe data is collected by volunteers. There are really two groups. The first group is teachers and students in a classroom setting. The second group, shown on the right, is citizen scientists. This can be anyone from the public, volunteering on their own, or in an informal education setting like a museum or library. How are the data collected? Globe has protocols, also known as standard operating procedures. These are step-by-step instructions for conducting and collecting environmental measurements, including specifications for which instruments are permitted. The full details of each protocol are available at the link at the bottom. Protocols with a smartphone next to them, like land cover and tree height and clouds, have been appified and are available in the Globe Observer app. How are the data collected? They're collected in different ways depending on what kind of measurement is collected. One way is through an automated weather station. Automated weather stations log measurements of things like barometric pressure, air temperature, and humidity every 15 minutes. That's a giveaway when you look at it in the database if you see data at regular 15-minute intervals. Data are also manually collected by Globe students and teachers. Think pen and paper method. Data are also collected by citizen scientists as well as Globe students and teachers using the Globe Observer mobile app. The Globe Observer mobile app is free for everyone and works on an iPhone and on Android devices. You can download the app for free from the Apple App Store or Google Play Store. Participants are required to complete training before contributing data. Participants complete training either in person, online, also known as e-training, or if they're doing the app, the training is self-contained inside the Globe Observer app. You can learn more about getting trained at the URL provided at the bottom of the slide. Wondering what kinds of data are collected? Here are two examples. On the left is a time series of air temperature measurements collected by a school in Latvia. The images on the right are from cloud observations submitted through the Globe Observer app by a citizen scientist. The person has used the app to report the amount of cloud cover, then submitted a set of 6 standardized photos with their observation. The release of the Globe Observer mobile app in 2017 significantly increased data coverage globally. Shown here is 12 months of clouds data from 2015 before the app launched, and then 12 months of clouds data from 2018 after the app launched. Now that you've learned about data collection, let's move on to Section 3 and cover the basics of accessing Globe data. Globe data are publicly accessible at globe.gov/globe-data. You can access Globe data 3 ways. First, you can pull up Globe data on a map and map it, then download what's on the map. You can also query the Globe database by protocol, date range, or other parameters and download it to a spreadsheet. Lastly, you can pull data using Globe's new API. This is a great option if you want to access large amounts of data or automate data retrieval. I will now demonstrate all 3 data access methods. So now that we've talked about where the data come from and how they're collected, I'm going to show you how to access it. First, I'm going to show you how to pull up Globe data on a map. Step 1, go to globe.gov. From here, go to Globe data. Since we're going to map the data, go to Visualize data. If you need more after this demo, when you come back to this page, there are additional tutorials, including a new tutorial on adding viz layers to ArcGIS Online. But for now, let's just enter the visualization system, which we call Viz. In this demo, I'm going to show you how to plot tree height data on a map. To plot any protocol data, first you need to add a layer. Since we're doing tree heights, we go to Biosphere. Here's tree heights. I'm going to select tree height measurements and tree photos. Hit Submit. The default for tree height data to display on Viz is to do 1 year, but you can also change it. You can scroll on your map. You can zoom in on your map. Let's zoom in and see what's going on in Fairbanks, Alaska. They've got some really nice looking trees up there. Right, you can keep zooming in. You can actually zoom in all the way to street level. And you can click on an individual observation to pull up more detail about that observation. You can see where it came from. You can see the picture associated with the observation. You can tell that this one came from the Observer app. Here's the tree height, date time. The latitude and longitude will be downloaded when you download the data. So if you go back to the photo, you can actually click and it will take you to the original photo that you can download. So if we zoom back out, you can see all of these observations. Anywhere there's an observation, you can download the data, or if you want to download everything that's displayed on here, you would go back to the protocol layers and view layer table. You can also download this layer as a KMZ. To do view layer table, export CSV, Save the file wherever it makes sense for you, and you're off. Now let's look at another way to access GLOBE data, and that is downloading it to a CSV file from a different query system. So you're going to go to globe.gov. That's always your home base. Go to GLOBE Data, Retrieve Data. This is called the Advanced Data Access Tool, or ADAT. The way I like to use it is first I'll go to Viz and map the data to see if it's available, and then I'll go to ADAT to do the query to download the data. This is good if you want to download a couple of hundred observations or a couple of thousand. If you want to pull large amounts of data, like tens to hundreds of thousands of observations, I recommend using the API. I'll show you how to use that after this. So for now, let's do ADAT. Enter the data access tool. Great. Here is the ADAT landing page. If you need more, there are instructions here, and a link to the data user guide that has additional information. I'm going to show you how to pull up land cover observations. That's a good one because it's fewer than 10,000 observations that we're going to pull. So that's a really good amount of data to use doing ADAT. Again, if you want to do hundreds of thousands, or let's say like 80,000, I would use the API, and we'll do that next. So first, let's select the protocol. We're going to do land cover. There are biosphere. Do land cover. Add to filter. We're going to specify a date range. I'm going to do the date range that we've had the app for. So the land cover tool and the app was launched in October 2018. Let's get as close as we can, and then you can adjust, sort of fine tune here. So let's say October 1st. We'll do till present. Add your date range to the filter. You can also filter by site name, country, school, or even if you have a bounding box for latitude, longitude. I want to pull all the data from the date range, so I'll leave it as is. You click Apply Filter. Obtain measurement data. Download measurement data. This sends your query to the GLOBE database. Give it a second. The larger your download, the longer this will take, but usually it doesn't take more than a minute or two. And you are ready for download. Click Download. Save the file where you want it. And you're off and running. So now that I've shown you how to pull the data up on a map, grab the data into a spreadsheet, now I'm going to show you how to use the API. This is a tool that allows you to do really large batch queries, say hundreds of thousands of observations. It also allows you to do queries from the command line if you're a computer programmer, and is really useful if you want to automate data queries so that you can do, say, write a Python script and routinely pull observations. So you're going to go to globe.gov. Oops. Globe.gov. This is always your home base. GLOBE Data, API. Like Viz and ADAT, the API also has a landing page with instructions on how to use it. For now, we're going to go right into the API interface. There are pre-populated query options here for you, so you can query the data based on protocol, a measured date range, country, polygon, site, user ID. It's a pretty flexible and customizable platform, so pretty great. What we want to do in this demo is pull clouds data from a date range. Let's do from the beginning of 2019 to September 2019. So we're going to do this one. It's going to tell you the query parameters and the accepted arguments. I really like this interface because it has sort of a try it out function. We're going to do clouds data, which is called sky conditions in this database. We're going to do January 1st, 2019 as our start date. And we'll do September 1st as our end date. The default is true, which returns GeoJSON format files. I want my data in a JSON format, so I'm going to select false. And then the default for this sample feature is true. And what that means is the first time you try this out, it's just going to spit out 10 observations. So that way it reduces the strain on the database, and you can test whether or not you're getting the right thing before you sort of do a full-blown request for data. So we're going to do true, then you hit execute. It's going to return the curl, so this is the URL that you can execute from the command line, the request URL, so you can enter this into a new browser window. That's what we're going to do next. And then it's returning, these are the 10 sample observations. So you can see the details of the observations, where it came from, when it came in, whether it's overcast, how blue the sky is. Pretty cool. And these are the response codes telling you that it was a successful query. So let's take this request URL, open up a new browser window, and paste it into the browser. So remember, this sample equals true at the very end. True, if it's true, it's going to return 10, but if you replace that with false, it will return the entire data set that you're asking for. So in this case, we want clouds data from January 1st, 2019 to September 1st, 2019. The power of the API is it's super fast. You're going to see success. I'm doing this in Firefox, so it has the option to do pretty print or raw data. Here you can see the raw JSON data. You can also view it as pretty print. I really like using Firefox when I'm doing the API for this reason. You can either copy the data into, say, something like a VI or an Emacs file, or you can just hit save. So we would do clouds data, or whatever name makes sense to you, and this is JSON. Hit save, and you're on your way. All right, folks, now that you've learned how to pull up globe data on a map, download it to a spreadsheet, or retrieve it with the API, I want to leave you with a few tips and tricks so that you know about additional resources on the globe website and on the Observer website that we didn't see before. So you're going to go back to globe.gov. This is the homepage you've just seen. But now we're going to a slightly different part of the website that you didn't see before. So you're going to go to Get Trained using the Globe website, and then you would click on Retrieve and Visualize Your Data. These are additional tutorials that you can refer to on your own time. They're really helpful. I recommend them. They're great. I also want to take us back to a new tutorial that's under Globe Data, Visualize Data. A new resource was recently posted, so maybe you say, I've seen the Viz system, I know how it works. I do want to point out a great new resource, and this is instructions on adding Viz layers to ArcGIS Online. If you click on this, it's going to ask you to download and open a Word document. If you click OK, what it's going to do is bring you to a set of step-by-step instructions on importing layers from Globe Viz system into ArcGIS Online. This is really great. I'll pull you up. Here's an example of the kind of thing that you can do. This is on the Globe website. Its sister website for Observer is observer.globe.gov. If you navigate to Get Data, it'll take you to this landing page. What I want to point out, there are also tutorials here for how to map and analyze data, including another one for ArcGIS Online, how to download special observations that are embedded in other observations. So in this case, it's dust observations that are actually embedded in cloud observations. And this includes a Python script for retrieving data from the API. You might find this helpful. There are also quick links here for how to pull up data quickly and easily on the Viz website. So we did the tree height observation. So if you actually clicked this, open it up in a new tab, these quick links you see, it would be viz.globe.gov/trees. And that's going to pull up the same data that we saw before. So if you're someone who really loves to repeatedly, say, pull up mosquito observations or tree observations, you can use that quick link provided here. These are quick links for all of the tools that are available in the Globe Observer app. The last thing I want to point you to on this website is a brand new resource. I'm very excited to share this, and this is the cloud data. So we retrieved the raw cloud data from the API in the previous demo. A team at Langley has gone through the effort to match Globe cloud data to satellite overpass data. They've matched Globe data with coincident observations from Aqua, Terra, Calypso, and geostationary satellites, including GOES, Meteosat, and Himawari. All of that data is provided for you guys. They've bundled it as the 2017 year of data. Here's the special eclipse event in North America in 2017. Here's the 2008 data. And here's a special bundle for the 1-month spring cloud challenge that happened last April and March. If you do use the data, make sure you cite it. Here's the acknowledgement and additional information about how the satellite matching was done, and a table with the data variables and definitions should you download that data. It's great data. Start playing with it. Thanks for listening, and we'll get into the next section. Section 4. Now that you've learned about how to access Globe data, who's collecting it, and where it comes from, let's talk about documentation. Anyone can use Globe data. If you do use Globe data in your work, please cite it following this citation. Global Learning and Observations to Benefit the Environment, Globe Program, the date you accessed the data, and the URL provided here that shows people how to get back to the data. If you have questions about Globe data or want more detail, refer to the Globe Data User Guide. This document is a technical document intended to help scientists and researchers understand, access, and use available Globe data. A PDF of the user guide is available at the link. You're probably looking at the data in ways that other people haven't before, and if you find issues in the data, we want to hear about it. If you find an issue in the data, you're encouraged to report the issue to help@globe.gov. Please include the following information in your email: your name, your organization or affiliation, your contact information, like your email, or if you prefer to be contacted by phone, a phone number, a brief description of how you're using data. The context really helps when we're troubleshooting on our end. Approximately when you discovered the issue, and a description of the issue. The more detail you can provide, the better. All right, we've made it to the end. So let's wrap up with a quick recap of today's trainings before we do Q&A. Globe is a worldwide community of students, teachers, scientists, and citizen scientists. Globe data are all made freely available to everyone. Globe data are available at globe.gov/globe-data. You can download the Globe Observer app for free today and start contributing your own data. Go to observer.globe.gov. A big thank you for joining us today. This webinar will be posted on the Observer website at observer.globe.gov within 1 week. If you'd like to stay connected with Globe, you can join our listserv for research and scientists. Use the link provided to subscribe. You can follow us on Twitter, or you can follow us on Facebook. With that, thanks for your attention, and we're opening things up for Q&A.